Sally Forth. Well, I won't repeat my name again, but okay. So during this time, I hope to kind of give you the big rocks of data analysis. How do you get to the right test? How do you conduct analyses and clean some of the data? And how do you get a draft of a discussion chapter? I'll try and be brief through this so I can kind of get to your questions. We have a small group today. Um, and I know some people have shared their projects. Um, Melissa will show you how to share projects in the chat. At any time, you can put in a chat, put in the Q&A, and I will seek to get to that. So let me just go through a few kind of critical steps, I'll say, of moving from basic raw data into a discussion draft. Okay, so for sure we have to understand levels of measurement and independent variables. I know many of you have taken stats classes a year ago, but nevertheless, you should have a clear understanding of what a level of measurement is and what an IV and DV is. Data cleaning, 95% of the jobs of your task is cleaning the data. So messy data, messy results. So the data has to be prepared appropriately. You have to select the right test. Why did you select the test that you selected? You should know that. And we'll talk about that. And there's kind of a basic template to kind of move through that process. Your results, I mean, we've articulated or developed intellectual statistics really in response to SPSS. You had 300 buttons, you had raw output, so we really tied together assumptions, results, and APA tables so you're not fussing with tables. You have other things to be doing than making tables. And then we'll show you the discussion draft, and then I'll get into the tool itself. So quickly, there's 3 levels of measurement: nominal, ordinal, scale. Nominal is just the names: red block, green block, blue block. Okay, no order to be had there. Ordinal does have labels. Horse came in first, horse came in second, horse came in third. There's an order to it, and they're named first horse, second horse, third horse. But they don't have to be equal intervals, okay? Equal distances or equal volumes in between those different categories. So, okay. I put down Likert type items. Really, that should really be bucketed under scale. I think just briefly, Likert items, 2 things. Likert items on a 3 or 4 point scale, keep as ordinal. Likert type items 5 to 7, keep as scale. And the other thing is, once you start adding or summing different Likert type items, like a knowledge score's got 10 items, once you start averaging or summing them, you're in scale land, okay? Just like when you were a kid, you had a 10-question test, you got the first question correct. That's a nominal level variable, correct or incorrect. But once I add up, I got 9 out of 10 correct, we're in scale land. Scale variables have both labels, 1 inch, 2 inch, 3 inch, has an order, and has equal intervals or spacing in between them. So that's that's more granular at scale. Why do we care about level of measurement at all? Okay, that's a question. Well, the reason we care is that particular types of statistical tests require certain levels of measurement. Okay, that's the reason. All right. You should know what an IV and DV is. Basically, good rules of thumb are DVs are the outcome variable and things that are really dependent upon the participant. It's their blood pressure, it's their 5K race time, it's whatever. So it's often just dependent upon their responses. An independent variable is typically controlled by the researcher. So I want to look at blood pressure differences by males and females. I want to look at blood pressure by day versus night, and so forth. So, so that's typically under the control of the researcher, not the participant, right? If we're looking at blood pressure by day and night, us, the researchers, deciding that, okay? The blood pressure is theirs, but the time we're looking at it is ours. If you are stuck with any of these things, join the club. Most folks struggle with what kind of tests to conduct. We have a decision tree built into the tool. How do you conduct it? And we've done a lot to, again, kind of integrate the assumptions and then really interpret those quantitative assumptions. We'll get to the qualitative, but at the moment, quantitative assumptions and interpreting whether or not a statistical Shapiro-Wilks for normality is indicates that that assumption is met or not, and it articulates that in English. And then what the output means, again, we kind of write it up in English, so you can kind of look at that and edit that. Loading up your data, when I do the demo, I'll show you this, but essentially you got to get to the tool. We're going to upload data in the projects tab. We're going to look at the variables to make sure everything is the way we want it. And then confirming the data is clean and ready. I think really by just running descriptives on that, that's going to give you a lot of information about that. Okay. So what is clean data? Well, I have a 1 to 5 Likert scale, but I have a 55. Okay. Obviously, data for human, data entry error. Okay. So we can look to clean that up. We do have a data cleaning wizard. This is really more kind of, I'll say it's really meant more for Qualtrics or SurveyMonkey. We have different number of headers. We can kind of eliminate the ones we don't need. In our tool, you need the variable name and you need the data underneath. You don't have any weird kind of coding of 1 male, 2 female, or whatever. You actually just put in male or female. So it's kind of straightforward, such that we don't really need a code book per se. Composite scores, I'll show you how to do that. Handling missing data. We do have, well, so we can impute missing data, one, but you should be careful about how that goes. So if someone is missing the first 8 of 10 items, okay, yes, I can impute a value for each cell. And by the way, the imputation works for both scale variables and nominal variables. However, that's not advised. So if people are missing, say, more than 20%, okay, of their data in a systematic fashion, you probably want to throw that person out for that for that variable. So just to underline that, so you want to see if your data is systematically or randomly missing, and then treat it as appropriate by imputing or not. Okay. Reverse coded items, simply some questions are asked in a negative form. I'm happy in the morning, I'm happy at night. Are you unhappy in the evening? Okay. So it's designed so people don't have response sets and just put agree, 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 agree. You know, so they want you to think through the process. Okay. So you would, you know, flip those responses and before summing what is my happiness during the arc of the day. Transform variables. There's a lot of different types of transformations. Sometimes you want blood pressure. You have a range of blood pressures, and perhaps you want, you know, normal versus high versus, you know, hypo. So there's reasons to categorize variables should you need to do that or want to do that. The test selection, this is not comprehensive, but it gives you, I'll say, probably a good 60 or 70% of what folks need. And basically, if you're looking at pair differences pre versus post, I know for a lot of the healthcare nurses online, this is often used, okay? And we're doing a pair t-test there. You have 2 time points. If you had more than 2 time points, we're kind of in an overland, so it's 3 or more groups, okay? So we're still comparing, well, it'll be a repeated measures ANOVA. So pairing t-test, um, if the level of measurement is ordinal, and you'll all get this video, by the way. If the level of measurement is ordinal, or the assumption of this is busted, violated, then Wilcoxon would be the appropriate test there. If we're looking at 2 groups, males versus female on blood pressure, we're doing independent sample t-tests because you have different groups that are independent of one another. Okay. 3 or more groups, I'm looking at, I don't know, the amount of sugar from banana to apple to orange, okay, or anything with 3 or more groups. ANOVA is your test of choice. By the way, the ANOVA also has assumptions, as does the independent sample t-test. And if those assumptions are violated, there is a Kruskal-Wallis test. So selecting a test is one thing, evaluating the assumptions is the next thing. And if the assumptions are violated, you want to kind of pivot to, they call them non-parametric tests. Association, sometimes people call, is there an association between A and B? Is there a relationship between A and B? So there's different kinds of verbiage to be had there. But nevertheless, when you're looking for a relationship, I'll say between 2 nominal variables, male and female, and cola preference, Coca-Cola, Pepsi, we're doing chi-squares. There is also associations to be had with scale variables. Does income and savings correlate with each other, relate to each other? And there's 1,001 different kinds of questions that can be asked there, particularly among different subscales within a particular tool. So it's interesting to see what's the relationship among these different domains. Prediction is the last kind of biggies. Linear regression or multiple linear regression and logistic regression. The key here is you'll notice in the IV group column could be any predictor. What I mean by that is nominal, ordinal, or scale. Okay. However, in the dependent variable, also called the criterion level variable or outcome variable or dependent variable, all I'm using synonymously. If the outcome variable is scale, we're doing a linear regression. If that analysis has more than one predictor, we call it a multiple linear regression. If the outcome variable is binary, live, die, yes, no, dropped out of school, did not drop out of school, whatever, we're doing a logistic regression, or called a binary logistic regression. Chapter 4. So again, we really tried to make it easy for you, mostly because the other ones were so kind of clunky. So we do have APA formatted tables. We do have plain English interpretation. You still got to put in your own voice. You still have to, understand what the heck we're talking about here in your own voice. And then there is different ways of visualizing that data, which is another way of communicating what has been found here. Okay. The discussion chapter has got several pieces of it. So the draft that Intellect and Statistics provides in a discussion chapter really has several pieces of it. One is it's going to summarize your results. So that's a nice kickoff to your discussion chapter. Hey, what do I got here? Did it meet my, how did my results align with my research questions? You have to then connect those results back to your lit review. We have not tied it to existing lit reviews. We should, but at the moment we're going out to LLMs to see, does your findings align with or contradict existing literature? That's an important piece of things. Um, that's just good science. That did I find something new here? And if you did, you'll want to double check that. I mean, you'll want to double check everything anyway, but you'll want to double check to say, hey, wait a second, no one in the world found this, but yet I did in my dissertation, so you should be suspicious about what you find in a positive way. Curious, suspicious, call it what you want. But nevertheless, it should tie to your lit review. Limitations, there's limitations to every study. We don't capture everything. There's covariates, there's sample size concerns with many of these things. That is to say that, hey, I didn't find significant results, but I have a large effect size. I didn't have enough folks to really have enough power to find differences if in fact they were there. Type 1 error. And then certainly the implications of future research. What does this mean for theory? What does this mean for practice? Where would other people go to look for additional research? I should also mention that it's going to be helpful. I don't know what the rules are exactly. I think it's 5 years or 7 years. You're supposed to keep your data. And if I understand it, for those faculty out there, I believe that journals are somebody could tell me. I believe that journals are requiring your data when you submit an article. Can somebody confirm or deny that if you've tried to publish recently? Um, if they don't, they should. And yeah, okay, I'll leave it there. But somebody can tell me. Okay. So the basic process, I mean, the name of this thing is from data to defense. So we're going, okay, so somebody said yes, I presume to my question that journals do require a statement about data availability. Perfect. From a couple of folks. Okay. And that makes sense. Okay. You want to be able to prove that your data is somebody can rerun it. Okay. Um, and in fact, we have a prof on looking at the data that, hey, co-work did one thing or co-pilot did one thing, we did another. Well, let's look at the same data. Let's conduct the same analyses and see if we get the same result. Um, okay, so the process we'll go through is to upload data. We'll clean some data. I got to find my my raw data here. I think I have that. Well, okay. Well, we'll touch on it. Clean data, analyze the data. Okay. Conduct analyses, conduct descriptives. Let me say something about descriptives to your benefit. You should conduct descriptives with every variable of interest. So not individual items per se, but composite scores, demographics, and read it. Okay. So I used to not conduct them, then I conducted them, and sometimes I forget to read it. And then after I've worked for 2 hours, I discover, oh, that sample size is incorrect. Guess what has to happen? I got to redo everything. So really look at it for your own benefit. The results is a draft, the discussion is a draft, and you can go ahead and log on now if you would like, and then We will sally forth here. Okay, and I think, well, we'll get to questions and answers too. I'll just, while everyone's logging on, just know Samantha is available via email or phone to assist students with consulting or a free 20-minute with me. Ashley, for our faculty, specifically a demo, a trial, courses. We have 60 or 80 courses for the quant. Some of those curated for healthcare, by the way. And then Melissa answers everything else, and then some. And phone, email, and a QR code. So, okay, so there's the login again, and then I'm just going to kind of get to it. Okay, so let's do that. So, dismiss. Okay, so let's go ahead to, I think I just upload data. Actually, well, you can so here's the tool. It's web-based. You're not updating things. The broad overview is projects is where you upload data, and you can upload from a different file format like Excel. You can paste a flat file from Excel into there. Uh, or for those using courses, we can choose an example data set, which I'll get to in a second. The management is where we kind of can manage data, create composite scores, download, manage data. Plots, oh, I can click on it. This may be too complicated. Data management is where we can do things like create composite scores. You'll want to download your managed data. That is, if you created a composite score or did some recoding, you want that data, for yourself. Plotting, 10 typical types of plots, which I'll show. Analysis, a whole range of things from descriptives, some of the correlations I talked about, some of the t-tests I talked about, ANOVAs I mentioned, regressions I mentioned, and then some of the other kind of chi-square stuff. There are other advanced analyses like mediation moderation, and this structural equation modeling as well. So the first four tabs is really kind of figuring out how to get data in, manage that data, visualize that data, and analyze that data. The three buttons below is really a decision tree to help figure out what kind of test you want. So I want to predict an outcome, thinking regression. My outcome variable is scale. Let's just go nominal. And does my DV have more than two levels? Nope. So I'm doing a binary logistic regression there. Once you have the test that you want, you can scroll into here and look at some of the assumptions of the analyses. By the way, LLMs are doing this just fine as well. But just to know, we have a data plan here that can be downloaded, edited, and referenced that you know is correct. And then importantly, we also have a power analysis also done before data one is collected, which is how many participants should I have? Right? So there are both theoretical and practical answers to this. So for a t-test, for example, you can say, hey, gosh, for a medium effect size, okay, there's different effect sizes there. For a medium effect size, which people will probably say is fine, I need 34 folks. Hey, gosh, the literature says that when I looked at these variables, so it was that had small effect sizes. And to detect small effects, okay, you need a large sample size for that. So theoretically, what does the literature say about the effect size of small, medium, large for those kinds of variables? And then there's the practical part of, particularly during COVID. Remember those days seem like they're gone forever, but it's difficult to get lots of folks. So these decision tree data plans are kind of a priori kinds of thinking that you should be doing. Okay. All right. Let's see if we can get some data in here. Let me just refresh this. I know somebody's trying to share with me here. Okay, so we have a few data sets, so maybe we'll just jump in here. Liz, I'm going to hold off on you for a second so I can kind of get overview stuff going. So and we could talk offline if we don't get there fully. But okay, let me just get with Nike. Let me just take a peek at that data
If you can raise your hand, we'll
and get
unmute you.
Nike. Take over that project for the moment. Okay, so this is a great example. Okay, all right, Nike there? Because I can work without that. All right, so um, setting up data is really important. Okay, so okay, is Nike there?
Yep. If
Hi,
you just
Nike.
unmute,
Hi, Nike. Come on in. I'm here. Okay, you're here, but we can't hear you. You're HERE, but not HEAR. All right. Well, I will just go ahead and make some assumptions here. So I'm going to assume that these 10 folks are the same 10 folks. Okay. And so we need one variable name and then the data. So we probably want to dump this or copy and paste that into up here. Okay. So this is probably best done in Excel, frankly. Um, so for each individual, you want data on one row. Okay. So I'm going to have all of my pre-test and post-test data for each individual, okay, on one row. I'm also going to put their confidence scores, okay, pre and post on the same row. I'm going to put their demographics on the same row, um, and barriers on the same row. So I should only have 10 rows here, okay?
Okay.
These are probably the titles, okay? These are probably the titles, and then just 10 rows there, okay? Then once we have that, I don't want to mess you up too much here, but I'll assume these are correct or incorrect. Let me just do this. Pre-1, pre-2. Okay. So let's just imagine we're calling it, well, here. Perfect. Control C, Control V. Okay. Keep going here. Okay. And this is covering a lot of cases, I presume. Okay. So really, we want to get the data correct. No data is back over here, so I'll assume nothing's in there. Let's get rid of those for the moment. Okay. So let's just let me save this. Let me just do this. So for Nike, I'm just going to duplicate your project because I don't want to mess you up over here. And then data grouped. So this is what I would do. So once I have knowledge questions pre and post, I want to get rid of this other stuff because this is going to be, as I say, on the same row. So just to make things, let me just do this. I'm not going to manage everything here, but just to exemplify some of what we want to do here. So I want to add columns. All right, I'm going to put roll in there. Seem like I'm missing somebody here. Uh, two. So that seems like I need. Okay, why is that not? I want everybody in there. Try this again. So I'm missing somebody. So make okay. So here's a thing that I just pasted, but guess what? It didn't paste that last row. I want to double check that. But I am curious about why it's not getting this last one here. Well, double check that, and then get rid of these other ones. All right, because they're going to be on the same row. So let's just imagine that this is our clean data set. Cleaner. And you want a clean data set to work with, by the way. You don't want it all messy. I mean, if you have variables that you really don't need, get rid of them. Um, this should be ID. And I want to get rid of this row. Okay. Let's call this our clean data set. Let's assume this is correct or incorrect. And then we want to create composite scores for our pre and our post. So we would just go to the variable calculator. Ah, so it only adds when, or averages when you have scale. The quick shortcut to that is to um, uh, edit variables. Nope. Levels of measurement. Uh, it's probably a quicker way of doing this. So let's just change them to scale. I want to do this differently though. Let's just do the third one. Let's recode multiple. Recode multiple, turn them into scale. Just put it back in the same variable. And it changes the modal scale. While I'm at it, I want to make this ordinal and make sure these are in the right order because otherwise the tables are going to be all yucky. Right order, replace the variable. Okay. And then variable calculator, just quickly. When we have correct or incorrect, we probably just want to sum them. So pre-test, we have a quick sum button that we can grab all of our pre's. Okay. We can quickly just grab our posts, sum, grab our post. You notice that new variable is made. And then that's 90% of the battle. Okay. So then we're going to go to analyses. Again, we have a whole range. We do descriptives first. We want to put in the variables of interest, which is really our demographics, and then our pre and post test. Notice these icons here for nominal, ordinal, scale. Also notice that there's other options to be had here with what we want in the descriptives. Okay, options there. Also notice that there's a video tutorial that gives a 3-minute overview of how to do this. Once you conduct the analyses, you'll want to go down So there's our APA table. There's a little write-up about it, but the most frequent role, for example, Nike would obviously see there's 8 folks here. Excuse me, 9 folks here. We really have 10. So we got to make sure that's all correct. And we would also look that, hey, gosh, I had a total of 9 questions or 10 questions. I cannot have a 99. I cannot have a 20. Okay. So you have those mins and maxes have to be reasonable. And then for the t-test itself, we would do a paired sample t-test because I'm matching the same individuals pre to post. That's the reason why we're doing a paired t-test. I have matched data on a scale variable. Okay. You should have those rationales for all your tests in your brain, or think about that. So here I could just like say I want to compare my pre-test to my post-test to see if the knowledge differs from pre to post. And here you can see there is an assumption. It's a normality assumption. It's assessed with the Shapiro-Wilk test. The tool runs the test and then interprets the test. That assumption is met. The results you can see were significant, yippee skippy. People mostly want to see significant results. So it identifies that it was significant. This is not the phraseology that you would typically use. You wouldn't say the pretest was lower. Typically, you're going to say post-test knowledge is higher. You can see that it's significant. And this little baby over here, that's the effect size. This talks about the chances of getting that T by chance. Okay, this happens less than 1 in 1,000. That D is the effect size, which is what is the importance of that difference? And the quick scale is 0 to 0.3 is a small effect, 0.3 to 0.5 is a moderate effect. North of 0.5 is a large effect. Well, you have 1.79, so it's a huge effect on knowledge. So you can kind of conclude that the intervention of knowledge education or whatever you did was important. One of the quick things that I'm going to keep moving along here, I want to just highlight the discussion chapter. I'll get there. Sorry, guys. I should put this up top. They're getting too long here. Okay. I'll get there. Okay. So here was a simple data set of Matchlock's burnout scale, depersonalization, exhaustion, personal achievement, demographic. I conducted some analyses here, descriptives, correlations, and so forth. But importantly, I ran a discussion chapter draft. And in that discussion chapter, which require you to identify the variables and talk about your research questions and so forth, there'll be an introduction. There'll be a summary of the findings, which does a nice job of putting it together. It's AI driven, so you got to double check it. What is the interpretation of this that is relative to the existing literature? What are the theoretical implications of your particular findings and practical implications and limitations and recommendations and conclusion and references? You got to double check these guys. Sometimes the DOI is off and so forth. So double check, double check. Nike, since you're on the horn, any quick questions you have for me?
Yes,
Hello.
good afternoon, and thank you so much for your time.
My pleasure.
I have a question that is
I'm listening.
to let all that apply question. How do I input the data and analyze it? Should I use the descriptive statistics only?
So you want to do two things. One is you need the variable name up here, like I did. And number two, you have 10 individuals. You need all of their data on the same row, all of their knowledge questions pre to post, all their confidence data pre to post, all their demographics, and any of these other barriers. So all you have one long row for
Okay.
participant number one. So that's how you input the data, and then just make sure that you don't have any any of this X business. You want to identify your variable name. So, and I think it's probably easier in Excel, frankly, just to export it. Okay. And then once you're there, it's just a nice, capture. And just, put these suckers, cut them out of there and paste them over here. Okay. And just kind of do
Mhm.
that business. But make sure that, you could see 10 pre, but that's fine. Just know that, hey, 10, we're dealing with confidence scores and so forth. So all on the same row. That's how you manage the data.
Thank you.
Yep. Any other questions, Nike?
No, I had a question that will select all that applies. I couldn't put it on here under the knowledge questions or the confidence questions. So for select all that applies, how can I
Well,
analyze the data?
let's just say select all. So this happens. So you have A, B. Hey, this person's A and B. Okay. This person's C and so forth. You have two choices.
Okay.
Choice number one is, so here's the recode. Choice number one is you have A, B, and then you have a new category called AB. That's the choice. Okay. The other type of recode is this. This is for A. This is for B. So here, you know, check, check. For B, I have, maybe zero there, or better yet. So it would be something like this. Okay. Absent. Okay, so your two choices are one is to recode them such that you have this. Sometimes that can be very messy though. If you have four options, you're gonna have 20 categories. Okay, so that's not really the best way. The probably the optimal way would be to make a new column for each option and then endorse whether it's present or absent. You only got 10 folks, it will take a second. So I think that's the ideal way to do that, okay?
Okay. Thank you.
Good question. That happens. And you want to, I know that we do have all that apply kinds of questions, but you have to think about when you make a question, what is that going to be reported like? You can have A B, A C, A D. Okay, that's three. So I think it's three factorial. So you have six different options. You have B with C, B with D, and then you have C with D. So we have six options. How many different options of the apply did you have?
5.
Well, there you go. We're gonna add another layer. So I think you 4, 3, 7, 2, 9. You have 10 different categories possible, including A, B, C, and D. Too many. You probably just want to do something like this.
Okay.
Because how meaningful it is to have somebody, one of your people that have A and D. So one of these two options is it, okay?
Okay.
It's a good question because it's a unique question. Um, okay. All right. Elizabeth, let's see what we got going on over here. Hopefully I can help. Elizabeth, I'm going to proceed. Okay, straight up. Okay, hi Liz.
Hi,
Hey, how you doing?
good. How are you?
Great.
Thanks for looking at this for me. So
Oh, we
this
haven't
is,
done it yet, but hopefully I can help.
yeah,
So this is
it,
our outcome variable here.
y- mm,
What is
that
our
is
outcome
the
variable?
independent variable. The dependent variable is column D.
D fixed. Okay, so you have a scale variable. So we're doing a linear regression, which you probably did.
I tried a few things just to see what would happen, but yes, I started with the linear regression.
Okay,
Then,
well, if you have a scale variable, that seems like that's the, good route to
yeah,
take. So,
yeah, this was my first opportunity to play with a real data set in here, so I just clicked all the buttons I could find.
well, we don't want to do that. I mean, I know you may be a very young person, okay? Because young people, they're like, let's try everything. And it's good because I'm afraid to do that sometimes. I'm like, but
Yeah, but no, the linear regression was the real one.
okay. So, and a linear regression should answer a question, okay?
Hmm.
And that question should be something like, does yellow uh, coded as no predict LTR fixed? Okay,
Thus, handing out the yellow sheet predict a top box rating on the HCAP score. That's essentially the question here.
give it to me one more time.
Does handing out a yellow sheet predict a top box HCAP score, which would be the
Right.
9 or 10?
Oh, okay. Well, you got something different going on there.
True.
So, so for that, you want this to be yes or no. So perfect, right? So that's exactly what you appropriately recoded. Well, you should recode. I'm sorry, 8 to 10 or just 9 and 10?
9 and 10 would
Nine and
be our
10.
top box.
So I would have so I would recode this.
Okay.
Okay. And I think I could do this kind of quickly. Famous last words. Okay, so recode. So binning, and really I'm taking this variable LT fixed, and I'm going to do a breakpoint at 9, and we'll see what that gives me. So this, I think that's including nines though. So I think I want a break at 8. So 8, this is under binning. So this goes to 8 and then 8 to infinity. I'm going to make a new variable. So let's just see what's going on here. So I can call this nominal. And I'd probably change this, 8 or less, or, whatever,
Hmm.
not top box. Okay, and then top box. How they came to that, by the way. They got to that top box.
No idea.
It
It's not
didn't
my
seem to
data.
say,
It came from one of our
right?
employees who asked me to look at it.
Yeah. So I mean, so I would just double check this real quick. So
Hmm.
here, so let's just do top box. So these should be all okay, nines and tens. Okay.
Hmm.
Uh, and then not top box should be eights. Okay, so hunky dory.
Good.
So our variables of interest is really this yes, no, yellow. So
Hmm.
really, we're going to go through the same process. We're going to do three things. Okay. One is we're going to get descriptives for our variables of interest, which is yes, no, and then our bin data. So I just want to peek at that and say, okay, hey gosh, yes, no, okay, and make sure that makes sense. Okay.
Hmm.
Then I'm going to want to run a chi-square because I want to say, hey, is there a relationship between these two things? Between my yes, no, yellow and my new variable? Okay. Let's see if there's a relationship. Because if there's no relationship, I may not go any further. So here that's called marginally significant. So there's an assumption, look at that. And then this is given the frequency of yes, yellow, not top box, yes, yellow, top box, and so forth. So I mean, these aren't rocking my socks off in terms of such a difference between what was observed and what's expected. You know,
Mm-hmm.
I'd want to see just quickly chi-squares. I call them lump detectors. And basically, a lump detector is if I had 50 men and 50 women and Coca-Cola and Pepsi as preferences, by chance, I would expect everybody to get 25, right? Half the men like Coke, half the men like Pepsi, half the women like Coke, half the women like Pepsi. So by chance, I would expect 25 in each cell. However, if all of the men like Coca-Cola and all the women like Pepsi, gosh, those are really large columns there. And it would be very lumpy if you imagined a two by two box with columns of 50 men liking Coca-Cola and 50 women liking Pepsi, and the other one's a flat. So you can
Mm-hmm.
think about it like a lump detector. So, quick sidebar there. This is marginally significant. So again, just like top box 910, 0.05 didn't come down from God. It came from a human being that said, here's a standard. So you could probably call that marginally significant. It's one piece of it. The other piece is you're going to want to do that, the second piece, which is the binary logistic regression. Okay. And that outcome variable is our bin data, not top box. And our IV is yellow, yes, no fixed. Again, for other folks, there's analyses in there. You know, that's that's because God did not predict it. Say 0.05, I could change it. Some people use 0.10, so forth, and videos. So if we just look at that, my guess is not going to be significant, but we'll find out in 2 seconds. So that is not significant. Okay, that's got to be 0.05 or less. Don't worry about the intercept. But if it was significant, okay, that is that yes, the yellow yes no did predict the odds, okay,
Mm-hmm.
of top box, okay. Um, it would share with you, hey gosh, the odds when you go from no to yes on the yellow, the odds of going from no top box to top box would be this percentage. It's an important question because you want to get the top box, you want happy people, patients, and you want to get paid for those happy people. Um, so it's an important question. And but for this analysis, it does not show that it's significant. Now you ran something and you did find significance. Is that true?
No, she ran it through Copilot and it gave her wonderful, happy, significant results. And then she wisely reached out and said, hey, can I trust this? And I figured I'd try it through here. And as you can see,
Yeah.
it's not significant. But then I was second guessing myself because it is my first time actually using Intellectus. So
Right.
I just wanted to be
Welcome.
sure. Thank you.
Join the
Um,
club.
One other
Uh,
question about this. It seems to me that there were plenty of patients included in this 3 months of data, but is there any concern that there just wasn't a sufficient sample size to reach significance?
nope.
Okay, that's what I thought. All
Nope.
right,
And
thank
if
you.
we went to the power analysis for
Mm-hmm,
logistic regression, just to double check that thinking,
mm-hmm,
177, 71, 177. So, but it's possible that it's difficult to detect these top box folks. But
mm-hmm.
177, I think you're like totally there.
I
Um,
think so too.
yeah. So I don't think that's the issue. I think the issue is a couple things. The issue is, hey, you know what? that was not a good predictor of that, or that didn't have a
Mhm.
large enough effect, whatever that entailed, to predict that odds ratio. So, the consensus at the moment is, although
Mhm.
it's close. I mean, and I would call it, I mean, a journal's not going to take it, but if I was the CEO of that organization, I kind of want to pay attention to that. Okay. So I think that's worthy um, of reporting as marginally significant. It's a big deal to have something that can impact the top box score.
Mhm.
Um, and I'd probably play around with it. I probably would play around by saying, what if eight was in that bucket? What if I got rid of eights altogether? Can it distinguish between 1 to 7 versus 9 to 10? Bet you it does. Um,
Why would you get rid of eights?
I'm curious to see if that intervention can pick top box versus these unhappy people.
Okay.
So I would just do a thought experiment. And if I filtered, let me just for the heck of it, if I just, I don't want that, but if I filtered, uh, okay, wait. Well, sorry, I already have, I already have the folks into top box or not, but I would read bin and just to
Mhm.
see, because that would still be important for me. People range from 1 to 10. If we got rid of those middle people, eights, the borderline people, and then I would do something with just eights versus that. What do we got to do there? What's predicting that split? Or seven, and you know what I mean? So I would
Mhm.
just think through different kind of tests to kind of get at what you know, to kind of drill into the data a bit.
Okay. Thank you.
Yeah, my pleasure. Okay, so final questions or thoughts. Let me see if I have any Q&A. I don't see any. Melissa, did I miss anything in the chat?
Yeah, I can put it in at the bottom though, so hold on.
Please type of test comparing three or more nominal or ordinal variables. So great. Um, so if I have if I have three, oh yeah, we're definitely in non-parametric land as a nominal or ordinal variable. And if I had, I'm not going to use what we just dealt with. So, but if I was comparing, let's just do this. If I had V1, V2, V3, and V3, and I had okay, and these happen to be and these and get out of this, and these happen to be ordinal. I should just did a quick sorry. And these happen to be ordinal. So we're kind of in, and I want to compare this V1 different than V2 to the V3. So I'm really doing a non-parametric test, and it's going to be the Kruskal-Wallis test, which allows the dependent variable to be ordinal. Okay. All right. So am I doing the right test here? No, I'm not doing the right test there. Um, it's going to be a Friedman test, part of me. So where I can put in my 1, 2, 3. Okay. So I'm comparing them. V1 to V2, V2 to V3, and V1 to V3. So Friedman test is the way to go. Play around with the decision tree though, is one thing. I also, I'd recommend throwing it into an LLM. Throw it into chat and say, I have three ordinal variables. What's the test of choice? Okay. That's going to simplify things pretty good. All righty. We're out of time. Um, Feel free to get on my calendar. Let me just, from the current slide. I hope this was helpful. We have other kinds of webinars around qualitative and for DMPs in particular. Thank you all for hanging in there, and we'll see you all next time. Oops. All righty. Have a great weekend, all. Cheers.